In this video, we're going to talk about the solar nebular theory. The solar system formed from an immense rotating cloud of gas and dust called the solar nebula. The sun's nuclear reaction began at the dense center of the nebula. The planets then formed by accumulating material within the swirling currents of the cloud. Planets near the sun evolved as relatively small spheres of rocky material. In the outer portions of the solar nebula, debris and gases accumulated to form massive gaseous giants. Here is a diagram of what we believe happened in the solar nebular theory. Here we have in picture A, a picture of the nebula, and notice how it's starting to collapse and rotate. This is then pulling in towards the center where we have the most material. You see a huge accumulation of material there. And also as things spin, sort of like the dough of making a pizza, it thins out as it spins. Here we can see in this picture, it's starting to flatten out a little bit more. And also the material in the center starts condensing even more. Here in picture C, the star actually starts to fuse, and that's causing it to get even bigger as it oscillates in size, trying to reach that hydrostatic equilibrium. Eventually what happens is it blows that gas outward, and then that clears out the debris in the inner region of the solar system. So here in D, you can see that that star has ignited. It's now blown out that excess dust and material, and those planetesimals are starting to collide and coalesce to form today's planets, which we see in picture E. That is our solar system today. So let's talk about the formation of the terrestrial planets. In the warmer inner solar system, the planetesimals formed from rock and metal, materials cooked billions of years ago in a core of massive stars. So our inner solar system is actually made up of material that appears to have come from at least two separate stars. These elements make up only 0.6% of the material in the solar nebula, and the faster collisions among particles close to the sun were more destructive on average. So the planets could not grow very large and could not exert large pull on hydrogen and helium gas because of their size. This is also what we believe formed the moon, which we'll talk about later on. We believe the moon and the Earth were actually, the Earth was actually quite large, larger than what it is today, and that a planetesimal came along and hit it and pulled material off of it. Even if terrestrial planets had hydrogen and helium, the proximity to the sun would heat those gases and cause them to escape. Hence, we have our terrestrial planets, Mercury, Venus, Earth, and Mars, and they're very dense, small worlds composed mostly of heavy elements, which were contained in the solar nebula. So let's talk about the formation of the Jovian planets. In the outer solar nebula, planetesimals form from icy flakes in addition to the rock and metal flakes. Since the ices were much more abundant, the planetesimals could grow to much larger sizes, becoming the cores of our four Jovian planets: Jupiter, Saturn, Uranus, and Neptune. The cores were sufficiently large, at least 15 times the mass of the Earth. And they were able to capture that hydrogen and helium from the surrounding. We call that the nebula capture. And it formed a thick atmosphere around those cores. They became the large gas giants. They're also low density because of that gas. And they're rich in hydrogen and helium, which are very light gases. And this is because of their dense solid cores. So here you can see how this nebula started collapsing. It could have been a supernova shock wave that came through. It starts to collapse and rotate. As it rotates, it actually condenses and gets smaller. And then, as you can see, it continues to rotate and gives us the solar system.